Morning to one and all. My name is Game Jagman. I'm from Mechanical Engineering. Today title of the topic is equal to discriminant functions and separating surfaces for classification. Discriminant functions and separating surfaces for classification. This presentation introduced the fundamental concepts of discriminant functions in classification tests. We'll explore how separating surfaces are used to distinguish different classes. Understanding these concepts is essential for designing effective classifiers and pattern recognition. Introduction to classification. Classification involving assigning data points to pre- predefined categories or classes. The goal is to develop a model that accurately predicts class labels for new data. Discriminant functions are mathematical tools used to facilitate this process. What are discriminant functions? Discriminant functions are mathematical functions that determine the class members of a data point is assigned to each class and the class with the highest score is chosen. These functions can be linear or nonlinear depending on the problem complexity. Linear discriminant functions. Linear discriminant functions are expressed as weight and sum of input features plus as a bias term. They create linear decision boundary or separating surfaces between classes. Linear functions are computationally simple and suitable for linear separable data. Nonlinear discriminant functions. Nonlinear functions involve in nonlinear transformations of input features. They can model complex decision boundaries for nonlinearly separable data. Techniques like NL methods are often used to implement nonlinear discriminant functions. Graphing nonlinear functions, quadratic functions to graph a quadratic functions identify the vertex axis of symmetry and roots. Exponential functions, the graph an exponential function plot points by substituting different values of into the function. Intercepts to graph a logarithm function identify the vertical asymptote and plot points using by substituting different values of x. Separating surfaces in classification. Separating surfaces are boundaries that divide different classes in the feature space. These surfaces can be lines, planes, or more complex shapes depending on the method. The goal is maximize margin or minimize misclassification errors. The skew surface and more surfaces in classification. They were occurred in surfaces can be lines, planes, or more complex shapes depending on this method. Types of separating surfaces. Linear classifiers create hyperplanes planes to separate classes in the feature space. Nonlinear classifiers can form curved or complex decision boundaries. The choice depends on the data distribution and the problem's complexity. Types of separating surfaces. The linear classifiers create hyperplanes to separate classes in the feature space. Nonlinear classifiers can form curved or complex decision boundaries. The choice depends on the data distribution and the problem's complexity. Linear discriminant analysis. LDA assumes normal distributed classes with equal covariance matrices. It finds a linear combination of features that best separated the classes. LDA is widely used for its simplicity and effectiveness in many applications. LDA is more combination of features that both separate the classes. It is widely used for simplicity and effectiveness in many applications. Predictor variable 1, predictor variable 2, and the quadratic discriminant analysis QDA. QDA extends by LDA, allowing different covariance matrices for each class. It produces quadratic decision boundaries for better modeling complex classes distributions. QDA is suitable when class distributions are not linear separable. Support vector machines SVM. SVM aims to the SVM to SVM define SVM is the support vector machine to find the optimal separating hyperplane To the maximum margin, they can utilize null functions to handle nonlinear operations. SVMs are powerful classifiers for both linear and nonlinear data. The role of the margin is the distance between a separating surface and the nearest data points. Maximizing the margin improves the classifier generalization ability. SVMs explicitly optimize this margin for robust classification. Another methods in classification enable nonlinear transformation of data into higher dimensional spaces. They allow linear classifiers to operate effectively on nonlinear data. Common nullers include Gaussian RBF, polynomial, and sigmoid functions. They allow to the nonlinear and classifier to operate effectively on nonlinear data methods. The transformation of the data into higher dimensional spaces. So mainly avoid and used in the main sigmoid functions and the nullers include Gaussian, RBF, and polynomial to the nonlinear data things, which are used to highest information data into the higher dimensional spaces. Fisher discriminant. Fisher, Fisher discriminant seek a linear prediction that maximizes class separation. It enhances class separability, maximizing between class variance related to within class variance. It is foundational technique in discriminant analysis. Fisher's linear discriminant classifier algorithm that can recognize scanned images of the 10 digits. One is contributor issues task force. It can be related to within the variance of the between class with the variant. In class variance and related to within class variance. It enhances separating by maximizing. Fisher discriminant seeks a linear projection that maximizing class separation. Fisher discriminant seeks a linear projection that can be the class variance. It is foundational technique in discriminant analysis. Comparing discriminant methods, linear methods like LDA and simple but limited to linearly separable data. Nonlinear methods like SVM Errors handle complex data structures. The choice of method depends upon our data distribution and classification. Comparing discriminant methods. Linear discriminant analysis with other classification models. Evaluating classifier performance metrics such as accuracy, precision, recall, and F1 score are used for evaluation. Cross validation helps assess model generation on unseen data. Proper evaluation ensures the reliability of the discriminant function. Actual positive, actual negative. Predicted positive, true positive and false positive. Predicted negative, true false negative and true negative. Accuracy equal to TP plus TN by TP plus TN plus FP plus FL. Precision equal to TP by TP plus FP. Recall is equal to TP by TP plus FL. Specificity equal to TN by TN plus FP. Challenges in discriminant analysis overfitting occurs when the model captures noise instead of the underlying pattern. High dimensionality can lead to the curse of dimensionality. Selecting an appropriate discriminant function requires understanding the data structure characteristics. Instead of the underlying pattern, the way used to can lead the curse of dimensionality and understanding the data characteristic discriminant functions requires understanding data and selecting an appropriate discrimination to the data characteristics. Practical application discriminant functions are used in face recognition and biometric authentication. They are applied in medical diagnosis such as cancer classification. Other applications include credit scoring and image classification. Summary of key concepts. Discriminant functions classify data by assigning scope for each class. Separating surfaces defines as decision boundaries in feature space. Choosing the right method involves understanding data distribution and complexity. Feature directions in discriminant classification. Advanced and deep learning are create new possibility for complex decision boundaries. Hybrid methods combine linear and nonlinear techniques for better performance. Ongoing research for focus on improving interpretability and robustness. To the combined linear and nonlinear techniques are better performance for the robustness. Conclusion and final remark. Discriminant functions and separating surfaces are fundamental in pattern recognition. Selecting the appropriate classifier depends on data properties and application needs. Continued research and development enhance the capabilities of classification system. References: Dua RO Hat PE Stroke and DG 2000 Pattern Classification, Second Edition Valley, Bishop CM 2016 Pattern Recognition and Machine Learning Springer, Christiani and Ensure Short Alert J 2000 An Introduction to Support Vector Machines, Cambridge University Press. Thank you.